People have asked me to teach them about closures. Closures may seem advanced, they may seem difficult, but in fact closures are in fact incredibly simple, and they are a language feature. A language feature that we must understand the programming language itself. And once we understand how the programming language works and executes, then we can understand closures in the most simplistic fashion. This lecture will teach you all about closures. So firstly, in order for you to understand closures, this language feature, you need to combine the knowledge of two separate topics, which is the main thread or the execution stack. You can call it either or, it's the same thing. And then of course we have the symbols table. And by understanding the symbols table and the execution stack, what you will have is the language feature in full view. Don't forget, it is a language feature. Closures are a language feature, and in order for you to understand them, you both have to understand what these two do and how they work together. So first of all, what is the main thread or execution stack? Well, you know that you have a function, and a function has braces, and between those braces you have your commands. It's just simply a list of commands, an execution context. Just like you with a shopping list, you are executing your shopping list item by item as you go through the store. Same thing applies here. You just have a function with an execution context with a list of instructions that you want to run at a set point in time. Now let's say I invoke the function. I want to run these lists of instructions. Well, does my function contain other functions? It can contain native functions that come with the language that are already predefined. So what it does is in my execution stack, it will look at all those sub-functions, it will add those to the stack, and then also it will add my function to the stack at the end. So that what happens is, what we do is we start to execute all of these functions one by one, and then finally we execute my function. This is called an execution stack, or you could call it a main thread. So you can think of it like one single strand, one single thread. And what we do is we add the beads on, those are each individual functions, and then what we do is we just take each bead off as we go along, and we execute them one by one in the correct order that the compiler sees fit. And then finally we have the output of our main function. That's called the execution context or stack. And then once it's cleared and we want to invoke another function in our program, it does exactly the same process. Now the second concept is the symbols table. The symbols table is basically a database for your values. Your program, the compiler, needs to understand where your values are so it can locate them. And what we have is something called a symbols table. You can look at this like a database for your compiler, and it stores your variable values. So if I create the variable a with the value of 10, it will create the symbol. You could look at the variable name as the symbol name of a, and it will have the value of 10. So we have this large database of our values. Now if you have a function, let's just say we have a very basic function that creates a variable a equal to 10, and it's a local variable. Well, what will happen is we will pop this function onto the execution stack. There's no sub-functions that we need to run or subroutines. So what we need to do is just execute that function. So it will create the variable or the symbol a, and it will be equal to 10 in the database, our symbols table. But however, once there is no reference, after this function is finished executing, nothing can physically point to a after this point. So the compiler, being very smart, says, look, this data can no longer be pointed to. So once it's finished executing, we can simply garbage collect or remove this value out of the symbols table. So we clean up our database. So our compiler always cleans up our database, our symbols table. Otherwise, it could get very, very large, very, very complex, and things could start going wrong. And we could run out of memory. So, of course, it keeps hold of the symbols table and it manages it. It garbage collects it when it sees values inside of the symbols table that can no longer be referenced in our program. So likewise, now what I want to do is I want to take a look at combining the understanding of these two, because when you combine these two together, you will understand closures in a very simplistic fashion. We now know that our program manages the symbols table and it looks at each symbol on a frequent basis. And what it will do is it will look at each value and it will find out, is there still a reference to this particular symbol, this particular value that's stored in our symbols table. If it is, leave it in place. If it isn't, remove it. So, let's say I have a function, but we can also have another function inside of another function, or we could have a main subroutine and a sub-subroutine. You can call it a function or a subroutine, just like making coffee in the morning is your subroutine for the morning. That's a function. And what we have is a function inside of a function. So what we're going to do is we're going to create a variable a in the outer function equal to 10, and we're going to have a sub-function. And this sub-function will be executed after the first function. So we're going to return this subroutine, this function. Once that function's finished, we're going to return this sub-function. Now, the compiler is smart enough to know that wait one moment. We're returning another subroutine. We're not executing it, but we are returning it. And this subroutine has a plus 10. So a, the symbol a, contains the value of 10, and also we say plus 10. So this will actually equal 20. So our subroutine actually contains a reference to the outer symbol a. So we need a closure. We need to make sure that everything stays together so that we don't get errors. So what happens is we invoke the first function. And don't forget, we're not invoking the second function. There's no parentheses, for example, calling that function name and having the parentheses and so forth. No, we are returning this function or this subroutine. We're not invoking it. So what happens is when we invoke the first function, the main outer execution context, what happens is we create the symbol a equal to 10. That's literally all that function is doing in its execution context. It's not invoking any other function. So what happens is that symbol is created in the symbols table and that function is simply removed off the execution stack. Now the returned function hasn't been invoked yet, but what the compiler does is it has a look at, after a function is finished executing, it takes a look at the symbols and it has a look to see whether there can still be a reference to the symbols table. So what you have is you have a, which is equal to 10, and it still can be referenced by the returned function. So what it does is it encloses it. It says, hold on a moment, we don't want to remove this symbol, and we want to wait for the next execution of the next function or subroutine because it still has a reference to this outer symbol. So it leaves it in the symbols table. And then we can execute the function that is returned again. And the function that is returned, execute it, and then it can finally reference the symbols table. And it can reference the a, and it wasn't garbage collected. So everything is enclosed together like a folder or a closure. And it folds everything up nicely together so that it has the data that it needs. And then once everything is executed, it can go through the symbols table and say, no longer can any other part of the program access this symbol A. We can't go back to the global scope and find this symbol A. So therefore what's going to happen is it simply destroys and removes that symbol from the symbols table. So that hopefully now shows you how execution context on the stack and how they execute is enclosed so the data can be used together, and you enclose everything together so that you don't get runtime errors. And they're actually extremely useful. So closures are simply a language feature and they allow things to be combined together to make things easy.